the general technique I would go and suggest my students to do this question is to construct. So this is the tactic. If you solve these bounds within the integration, you're going to get that equation, the final equation you want, without having to find any constant c. As you can see, I'm always careful, right? Even I'm this careful, I still make mistakes. Last time I made a mistake about bounds, I won't make it again. Okay, 1 to 4. Uh-oh, I see something. I see something, I think. No, I don't see anything. So I'm going to make that up, right? Just to get some method marks. I can integrate that, can I not? Wait, how come? Does it say it passes phi? Now I wonder. Oh no! I need to hit my head at the wall. Right, I didn't see that, honestly. The honest feedback here is that it was quite high. It's me again, Krubase. Today I'm going to walk through another paper, Pure Mathematics P4 IAL syllabus. This is actually the most challenging paper in Pure Math. So this again is going to be a live walkthrough on an unseen paper. You can use chapters in the description to jump to any question you want. After I hit the timer, there'll be no cuts, no edits. Are you ready? So the timer has started. Let's begin. Okay, so just gonna write on the right part here. And number 1, let's go, guys. A, find the first 4 term of binomial. All right, binomial. Seems like the first term of the binomial here isn't 1. And remember, we have to make it 1. So the general form of binomial in the formula sheet would require so that you have this kind of form. Yeah, but x can be anything. So yeah, this is going to be, if you look at the formula sheet, it's just 1 plus nx plus n times n minus 1 over 2 factorial and x squared and so on. But we need the first 4 terms, so that's going to be up to, yeah, it's going to be up to x cubed, right? Because that's the 4th term. So let me write that down maybe. So n minus 1 and times n minus 2 here. And that's going to be divided by 3 factorial. But actually, I'm going to have to multiply all that by x cubed here. So I'm out of space there, so I think you don't mind. All right. And then, so that given binomial there, we need to make it so that the front term here isn't 8. So what I can do here is that I can sort of like take 8 out and then do that. So that's going to be 3 over 8 instead. But be careful because I have taken 8 out. So I need to power back entirely by minus 1 over 3. So if you try work backwards here to check, it's still 8 minus 3x, all to the power of minus 1 over 3 there. All right. Okay. So here, if we expand the power in, right? So we're going to get 8 to the power of 1 minus 1/3. So that's it's like 1 over 2, right? So we get 1 over 2 here. You can check in the calculator. And then that's going to be the actual binomial here. So this is a minus 1/3. So first 4 terms, all right? So this is 1 over 2 outside. So 1, yeah, up here, plus n, which is that, and then x, which is the whole second term there, including the sign. Yeah, include the sign, guys. Okay, and then the next term is that, n, and then subtracted by 1, so I get minus 4 over 3 there. So that's n and n minus 1, all right? And then divided by 2 factorial, which is 2, and then the second term squared, and then the 4th term here, I'm just going to put down here maybe. So that, we probably have to write everything like this, right? Because we need to get the method marks, okay? So 3 factorial, I'm just going to put as 6, right? Yeah. Because it's 6. And then that is going to be cubed. So I'm just going to end there. All right. And yeah, we're going to simplify. Okay. So the first term here is already simplified. So I'm going to put 1 over 2 in there already. Okay. The second term here, minuses cancel. So I get 3 cancel 3. So I get 1 over 8 here. 1 over 8 times 1 over 2. So I get 1 over 16x, right? Just going to use some mental math there. It's quicker. Okay. So we have 4 over 9 here. So 4 over 9 over 2 is 2 over 9. 2 over 9, yeah? And multiplied with a 9 over 64. All right? Okay, so I get 1 over 32. 1 over 32 times 1 over 2. So I get 1 over 64, yeah? With a positive sign again. This is x squared, all right? And then this seems like another positive term because we have 3 minuses here and another 3 minuses here. So all the minuses cancel. I'm just going to look at that. And then, there's a lot of numbers here. So I get, so there are 3 3s here. We'll cancel with the 3 3s here. And then I get 8 to the 3 at the bottom. So that's going to be 4 times 7 over 6 times 8 to the 3, right? X cubed there. And I also have another 1 over 2 here. So I'm just going to put 2 here. Okay, there you go. Yeah, so I'm happy with that. So 2 to cut this, I get 3. So that's going to be what? 8 to the, my calculator here, 8 to the 3 times 3. That's the bottom. Okay, so that's going to be, ooh, that's quite a large number. Yeah, I think it can cancel with 7, no? No, it cannot. Yeah, that's fine. So we're not going to cancel anything. So that's going to be 7 over, yeah, because we don't have anything multiply 7 there. 7 over 1536. Yeah, that's the 4 terms there. Ooh. Now, question B, use the answer from part A with x equals 2 over 3 to find the rational approximation to that. Okay, so we're just going to put everything into the form here. So we have 8 minus 3, 2 over 3 here to the power of minus 1/3. And then I'm going to put that equal to the expanded binomial form here. So it's a half plus 1 over 16, and this is 2 over 3, right? Plus 1 over 64. This is 2 over 3 squared. And then that 2 over 3 cubed. So we need to seek the cube root of 6. All right, we'll find it somewhere. All right, and then we make that, we isolate that and show that, show the approximation to that. All right, so the left-hand side here we have what? 8 minus 2. It is that. Okay, so let me just make that the subject. Okay, I think this here will have root 6, cube root 6 already. So this is 6 to the power of minus 1/3, right? Which happens to be 1 over cube root 6, yeah? Okay, which happens to be that. Okay, so we probably need to do all the fraction here, which my calculator is not capable of doing that. So I think I'm on my own with that. So 1 over 2 plus 1 over 24 plus, so this is 4 cut 64, I get 1/6. So that's 1 over 4, 1/6. Okay. I think I'm gonna make it help me a bit on fraction here. 1/64 multiplied 4 over 9. Yeah, that's bad. Okay, maybe not. So what was it just now? I got 16 times 9 at the bottom. So yeah, so that's 16 times 9 at the bottom. Yeah, I get 1 over 144. Yep. Okay. And then plus the last one here. I think 1536 is kind of like divisible by 8 because we just got it from there. So yeah. So that's going to be, if we cut the thing, we get, ooh, that's a large number. Okay. So that's going to be 7 over 5184. Okay. And if I do all those fraction, I get the approximation. I just flip the fraction basically. So 1 over root 6 equals, You just simplify the fraction here. Seems like 5184 could be the lowest common multiple. Let me try 5184 divided by 144. See if I get it. Yeah. So that's 36. So okay. So let's do a long fraction here. And then that would be, so 5184 divided by 2. That would be 2592 plus 5184 divided by 24. I get 1216. Divided by 144, I get 36. And then that is just 7. Okay, so that means root 6 is approximated to be 5184 divided by all that added up. So 2592 plus 216 plus 36 plus 7. Yeah, so that would be my answer there, guys. We sure should check back with this, right? Because I'm still in doubt with this number here, but yeah, I'm gonna do that again now this time. Okay, so 3 cut with all the 3's there. And then I have 28 here. Let me write that down. So 28 here, 3 cut 3. So this is 8 cubed times 6. Okay. And then I have another 2 here. So 8 cubed times 6 times 2. Yeah. And then 28. That divided by 4. Yeah, I think I'm happy with that, guys. Okay. I'm just going to run away now. Okay. So next question, question 2. Okay, question 2. The curve C1 has equation that C2 has that. Use algebra to prove by contradiction that C1 and C2 do not intersect. Okay, contradiction. So the assumption, yeah, because proof by contradiction, we need the assumption first. So the assumption is that C1 and C2 do intersect. Yeah. So by this assumption, we will assume that they do intersect. And when they do intersect, they have at least the answer to the equation we're going to make right here. So we make them intersect. That means x to the 4 plus 10x to the 2 plus 8 equals 2x squared minus 7. Okay, so we rearrange there. So x to the 4 minus, plus 8x to the 2 plus 15 equals 0. Okay, so just going to tidy up that a little bit. Okay. So seems like I can do factorizing here. So x to the 2 and x to the 2. We don't need to let anything be anything. Just that will do. Right. So yeah. See, guys. Seems like these two brackets don't give you any answer, right? So x to the 2 equals minus 1 or x to the 2 equals minus 5. So no solution. No solution to x at all. Well, what does that mean? We need to write some context here. This means that there won't be, there are no, right? Just make it stronger there. There are no intersections between C1 and C2. And when there are no intersections, it contradicts. This contradicts the assumption that C1 and C2 intersect, right? Therefore, C1 and C2 do not intersect, all right? Yeah. Wait, hang on. We assume that they do intersect. Yeah, it contradicts. Yeah, okay. All right. So that's it. That wasn't too bad because we have now proved that there's no solution to this. Okay, cool, guys. Number 3. Now we have a curve C with parametric equation. Good. Okay. Show that dy by dx is that. Well, okay. The easiest way to do that is a chain rule. So dy by dx is equal to a chain rule, dy by d theta over dx by d theta, right? Because theta is the third variable here, which is kind of like make it parametric. Okay. So now dy by d theta is just differentiating 1 plus cos 2 theta. So differentiating 1 goes away to 0. So differentiating cos 2 theta, we're going to get minus sine 2 theta. Differentiating cos, we get minus sine. And then don't forget the chain rule. So we should have a times 2 here outside, the derivative there. And then dx by d theta. So differentiating 3 sine cubed, we need to bring 3 down. So multiply with the 3 in front there. And the sine will reduce the power by 1. So that is sine squared. And don't forget to do the chain rule of the sine afterwards. So we get a cos here. And that would be it. Now we need to prove it to cosec theta. Okay, so we have a sine squared here and a double angle there. So because the required form doesn't have any double angle, that is a big hint to me that I should change that to a double angle. So I'm going to get a 2 and then a 2 from the sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So I get a 2 out multiplying with the 2 there. I get a 4. Okay, so 4 sine theta cos theta here. Still all divided by 3 times 3 is 9. So a sine squared, I'm just going to keep it. Yeah. Cos squared. All right. So cos cancel with cos. And then sine cancel with 1 over sine. I get minus 4 over 9 cosec, right? Because the reciprocal of sine is a cosec. All righty. That is fine. So k is minus 4 over 9. Just telling that, yeah? No big deal. So this is A. This is B. The point P lies on curve C where theta is pi over 6. Point P lies on C, okay? Okay. Find the equation of tangent to C at P. Giving you answer in blah, blah, blah. Okay. So we probably need to find dy by dx first, right? Because tangent is all about gradient at the curve at the point of the curve at the point. Okay. But this is dy by dx when theta is pi over 6. So that's going to be equal to substituting to the form we got. Because we already got the form in theta, so we should use it. Cosec pi over 6. Now, I happen to know that, of course, everybody knows that cosec is 1 over sine, but then sine pi over 6 is just sine 30 degrees, and sine 30 degrees is 1 over 2. So we have a 1 over 2 there, so it's like minus 4 over 9 and 1 over 2, guys, because we need to make it 1 over sine, right? So that would become a 2, so that is minus 8 over 9. Yeah, just do the math there. Adding a page. Now we already got the gradient here, so the next thing we do is get the x and the y at this theta equals pi over 6. So x is equal to 3 sine cubed of pi over 6 here. And that's going to be what? Again, sine pi over 6 is 1 over 2. So 1 over 2 cubed is 1 over 8. So that's 3 over 8, yeah? Okay. And y at pi over 6 is 1 plus cos of 2 theta. So that's pi over 3 because we have to multiply pi over 6 by 2. Cos pi over 3 is also cos 60 degrees, which is equal to 1 over 2. So that is adding with 1, we get 3 over 2. Happy? Then we can plug it into the linear equation formula. So y minus y1, I'm just going to take y1 as being 3 over 2 there. M is already found to be the dy by dx, which is minus 8 over 9. And x is just 3 over 8. Seems like we have a lot of fractions here. If we multiply everything by 36, no, that's not going to do it. So what's the lowest common multiple here? 32, 72, 72, I guess. Yeah. Okay, so multiply all by 72. So 72y minus 72 cancel with 2, I get 36. 36 multiply 3, I get 108. Is that right? Yeah, gotta be sure, guys. Okay. 9 times 72 would be 8, so that's minus 64x, right? Expanding in already. Oh, right, hang on. I forgot that, yeah, all right. So, no, I think I'm just gonna multiply by 18, right? Because I forgot that this 8 can sort of like cancel the 8 inside there. So I'm just multiplying by 18, sorry. So y minus 18 cut 2 is 9, so 9 times 3 is 27, right? Equals, so 8 multiply 9, I get, oh, hang on, this has to be 18, almost. Yeah. So 18 times 9 is 2, so minus 16, and then x minus 3.3 over 8. So maybe I'll slow down a bit, yeah? So minus 16x, and then minus 16 multiplying in, I get first term minus 16x, and then 16 cut 8, I get 2, but the term has to be positive, so I get a positive 6 there. Okay, just making sure. All right, so if we move everything to the right side to follow the form there, we get 16x plus 18y. 6 has to subtract from minus 27, so that is minus 33 equals 0. So that is the required form. Okay, so that's B done. C, show that C has Cartesian equation of that. Okay, so usually when you see parametric trigonometric equations, you can just play around with the trig identity and trig double angle and everything. So I'm looking at sine cubed here. Let's see. Okay, so I think I'm gonna do it like this because y is equal to 1 plus cos 2 theta is also 1 minus 2 sine square theta, right? Agreed. And so you can have 2 minus 2 sine square theta here for the y. But then if we sort of make sine squared the subject here, right? We're gonna have 2 minus y divided by 2. Okay? Yeah, so far so good, right? Yeah. So if I want sine to the 3 theta, I need to power the right side by 3 over 2, right? Yeah. So it's like I power on both sides by 3 over 2. Okay. And because we know that sine cubed theta is x over 3, right? So I'm just gonna make this side x over 3 already, equals everything there. Okay, good. From this, yeah. And then if I square both sides, right, I get x over 3 squared equals 2 minus y over 2 to the 3. So that is kind of like similar now, because on one side we get a cube, on the other side we get a squared. Well, expanding everything, guys, I guess, this is 27 equals, I'm just going to keep 2 minus y cubed here unexpanded, because that's what we want. And then on the bottom, I get 8 here. Yeah? Ooh, so I don't have a 9 there. Okay. Oh, sorry. So this is a 9. My bad. It's just square, not cube. Okay. Almost. So x, 8x squared here, and 9, 2 minus y cubed. So that is as required. Okay, so I think that's it. Oh, we got to find the domain where q is the constant to be found. Okay, okay. So that's the domain, right? So the domain seems to be where y equals 0, right? So we can find that. Okay, let me think about that a bit. We can look at x being maximum from this function alone. This is important. So think about the maximum value of sine theta. That cannot exceed 1, can it? Right? So x max there is just 3 times 1, which is 3. So we know that this should be 3. That means this should be minus 3 because sine theta could also be minus 1, the minimum. The minimum could also be minus 1. All right, so x min is 3 minus 1 equals minus 3. So that means the domain of that Cartesian would be minus 3 equal less than x equal less than 3. Also that, right? I almost forgot to find that. Okay, so next question is question 4. That seems to be a another coordinate geometry question. Okay, we verify that P lies on C and P is 0.12. So we're just gonna subs, right? X equals 1 and y equals 2 in the equation. Okay, just substitution basically. And by verify, it means that if we make the equation true, then it is true. Okay, so just, yeah, mental math there. So this is 3 plus 8 minus 8 plus 8 minus 11. So that cancel or cancel. This is true. Okay, so P lies on C. That's part A done. Part B, find dy by dx in terms of x and y. So this is implicit differentiation, guys. Okay. So you gotta differentiate the whole equation without caring much about rearranging. So differentiating, so we're gonna differentiate d by dx of the entire, okay, let me write that down, all right? Okay, so just repeating everything here. So it's like we are applying the operation d by dx or differentiating respect to x for all the terms. If we apply d by dx to the first term, we get 6x, right? Just simply respect to this expected variable there. But when we differentiate the second term here, we pretend like we would differentiate as if this were x, but it is actually y. So we would get 4y. I mean, as if it were x, right? We would get 4y, but then you just add dy by dx. That's just the easiest way to get going with implicit, right? And this one would require product rule. When you have an x and a y, there are two separate functions. So I'm just going to do 4 and then brackets, x, x, and then dy by dx. That's the u dv. Yeah, u being the front one, v being the other one. And plus v du. Du is dx by dx. So that's it. Now the next one, differentiating an exponential. So that is an exponential of 8 being the base. So we get 8 to the x, but then we have to multiply along 8. Differentiating 11 goes away, so that's 0, and this is equal 0. We want to isolate dy by dx. So we need to capture dy by dx in all the terms. So it's like collecting them. Okay, so I'm going to move everything that is not dy by dx related to the other side. So I'm going to have 4y dy by dx here, and then minus 4x dy by dx, expanding that brackets. And then on the other side, right, I have a minus 6x, this guy going away. This guy is kept, this guy is kept. So this is a minus 4 and a y, so we have a plus 4y here, okay? And then this whole lot is a ln 8 times 8 to the x, being a negative, don't forget, because we move to the other side. Okay. So if we isolate dy by dx, we need to factor that out. We get a 4y minus 4x here. And then, well, this can be 4y minus 6x and minus ln 8, 8 to the x. So there you go. Dy by dx as a subject, we have 4y minus 6x minus ln 8 times 8 to the x, or divided by 4y minus 4x. We could factorize 4 out, but I guess we don't need to in terms of x and y. Yeah, so that's done. Okay, so C, sorry. Should be C now. Question C, the normal to C at P crosses the x-axis at point Q. Okay, normal to C at P. Okay, so we need to find, well, we already know where P is. So we need to find the normal at P. First, we need to find the tangent first because it's going to be perpendicular to the normal. So dy by dx at P. So we need to substitute x and y into our derivative form here correspondingly. So 4y being 2. I have to be careful here. You have to be careful. So x being 1, ln 8 times 8 to the 1, because x being 1, and 4 times 2, because y is 2, minus 4x is 1. That's the coordinates of point P, guys. Yeah. All right, so that's just that for your reference. Okay, so let's do some exact value here, just to be safe, because it seems like the final form should be exact. So we're going to get 8 minus 6 here being 2, so 2 minus 8 ln 8, yeah? Not going to do anything there. And this is 8 minus 4, so we get a 4. Simplifying a little bit by 2 on every term, we get a 1 minus 4 ln 8, right? Over 4. I was thinking that we could actually, wait, hang on. We cut 2, right? So that should be a 2, not a 4. Okay. So I was thinking ln 8 is actually 3 ln 2 using log property. And that's going to make me, yeah, because we need ln 2 here. So that makes sense. So this is, so that's 3 ln 2 multiplied 4. We get 12 ln 2, yeah? Okay. So that should be fine. That is the gradient of the tangent. So the gradient of the normal would be minus. If we put the minus in that fraction, it's going to switch these two guys and swap the top and the bottom. So that would be 12 ln 2 minus 1. So that's the gradient of the normal. Okay, now we get the gradient of the normal. Are we ready to find the normal? Yes, because we already know where the normal passes, which is also point P. So y minus y1 still being the y of point P being 2 equals the m, 12 ln 2 minus 1, times x minus x1. Multiplying every term by 12 ln, okay, hang on. We don't need to find the linear equation because we don't need to. We are asked to find the x coordinate. Yeah, the normal C at P crosses the x-axis at point Q. So crossing x-axis mean y equals 0. So we're going to put y equals 0 here. So 0 minus 2 equals all that again. And then we need to find this x, guys. Okay, so multiplying this denominator to the other side with the minus sign here. So I'm going to get 2, switching the term, right? Because there's a minus sign. Plus, no, minus. 2 multiply 12 here, I get 24 ln 2 equals 2 expanding in here, I get 2x minus 2. All right. Well, actually, I don't need to do that. I can just cut by 2. Okay, so I'm gonna cut by 2 here to cut. So that's gonna be 1. That's gonna be 12. So I get 1 minus 12. Oh, why do I change color? I guess that's fine. And then x would be equal to that move to plus, so I get 2 minus 12 ln 2. I think that's fine. So yeah, that's my answer. A and B are integers, of course they are. Yeah, that's my answer, guys. All right, so next question 5. We are at 33 minutes. I think I'm still okay with that. Figure 3 shows a container in the shape of hollow, inverted, right? Blah, 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 blah. Okay, show that V is that. Okay. About volume, when the height of the water is h centimeter, the surface of the water has the radius r, okay, from the diagram. and the volume of the water being V. All right, so this is basically similar triangle, guys. If you see cone like this, and there is the volume underneath the top surface like that, yeah. So if we look at the side view here, okay, we're gonna see that it's gonna form similar triangles. So this is H, this is hang on, and this is R, right? This is 12, yeah, and this is 30. Okay, so we have the ratio there is 12 and 30. Okay, so according to similar triangle, we can do like R over 12 equals the smaller one, H over 30. It's like smaller one divided by the larger one correspondingly for the sides equals smaller one divided by the larger one. That's usually the way I go with that. So the point here is to find R in terms of H, because if you look at the volume there, we don't need any R's, right? So R in terms of H would be 12 over 30 H, and that would be 6 over 15, no. Yeah, I can do 2 over 5 H, just using 6 there. All right. So V of the volume of the water would be 1/3. Yeah, that's formula of the, yeah, it gives you the formula of the cone there, but I happen to know. Pi R squared H. Okay, basically that. So that is that's 4 over 25 in the brackets there, 4 over 25. So that's 4 over 75 pi H cubed as required. Okay, that's A done. B, given that water flows into the container at a constant rate of that. Okay, so this is rates of change. Yeah, water flows with the rate of that. It's like adding in water. So this is dV by dt given here. Okay, 2 pi. Now, that means we need to form, so the general tactic I would go, the general technique I would go and suggest my students to do this question is to construct the chain rule equation first. Now, before doing that, we need to think about what are the relevant variables here. So we have a V, an H, and a T. So that could go like dV by dt, or we can just read the question and actually, yeah, so we want dH by dt. We can do it like this. So because we want dH by dt, that is the rate at which H is changing. So dH by dt is needed here. And you can do your chain rule. So dH by d, the other variable, which is V, and times dV by dt, right? So if you try cancel the fraction here, dV would cancel, and you get it back to dH by dt, but that's not what we want to do, because we want to substitute dV by dt as 2 pi, and dH by dV need to be determined. All right. So, but, you know, because we already have the function of V in terms of H, so we can do dV by dH. And if we want dH by dV, we just flip that, right? So dV by dH, just differentiating this thing respect to H. So 3 is a polynomial here, bringing it down. So 3 multiplied 75 there, sorry, multiplied 4 over 75. 3 can cancel 75, so I got 28. So that is 4 divided by 28 pi H to the 2. All right. That's dV by dH. That means dH by dV would be flipping everything. So 25 divided by 4 pi H squared. All right. So dH by dt, we can find it to be that first multiplied 2 pi, because we already given dV by dt. Okay. Now it says 1.3 minutes after water starts flowing. We need to use that information to find dH so that we can plug it in here and find out dH by dt as required. Okay, guys, I'm thinking of how to do that. So, okay. All right. So the time given there can be used to determine the volume. Aha. because don't forget the volume, the rate of volume here is 2 pi cubic centimeters per second, right? So volume should be 2 pi times the time taken in seconds. And don't be tricked by the units because that's going to have to be converted to seconds. So 1.5 times 60. So this will have been the volume that the cone has inside the bigger cone. Yeah, the water cone. This is the volume of the water cone, if you like, the one with the H and the R. So this is basically what? That's 90 there altogether. Yeah, and 180. So this is 180 pi. Yeah. And the volume is 180 pi. We can use the volume to find the H here because we also have the equation linking them together, right? Yeah, hang on, let me just do stroke here. All right. So if you want to find just H, we're going to get, so it's going to be V times 75 divided by 4 pi, and then cube root. And then we're going to use this in there. Okay, so we don't need to find it in any exact value. That's good. Okay, pi cancel. It seems like I might be able to just simplify these if I want to, but let's see. So 2 cancel that, I get 90. 2 here, I get 2. 2 cancel again, I get 45. Okay, so that's interesting. So this is cube root of 49 is 3 times 3 times 5. 75 is 5 times 5 times 3. Isn't that wonderful? So we get a cube root of, you know, groups of 3 things multiplied repeatedly. So that's a 15 basically, because I can take 1 3 out and 1 5 out from those. So that is the H. Happens to be a nice number. That means dH by dt now will be solved to be 4 pi 15 squared times 2 pi. And pi will cancel nicely. 2 will cancel with the 4 here. And that will be, so that's 25 divided by 2 times 15 times 15 first. And then 1 5 cancel there. I get 5 over 90. Oh, hang on. I can also use 5 and another 5 here. So 1 5 and another 5 here. So that is 1 over 18. So that would be my answer there, guys. 1 over 18 cm per second. Yeah, that's nice. Nice number. I like that. Yeah, I think that's right. Okay, next, number 6. Number 6, use substitution. I like substitution because it already tells you what to do. Yeah, okay, so because u is that, so we're going to do differentiating first, du by dx. So that is, okay, I'm just going to write it again, d by dx of that to the power of 1/2. That's du by dx, yeah? So a power of 1/2 here, we're going to do chain rule. So we bring the power down first, and the power is reduced by 1. So that's going to be minus 1/2. And then the chain rule inside here, we would have to multiply 3x to the 2. All right, that's fine. So if we make dx the subject, we would get, so this is 3 over 2. So how do we do that? So it's 2 over 3. Moving the other side, that's going to change to a positive, and over x squared here, and then du, right? Just doing the algebra there, guys. If you're not happy, you can stop and check a bit because I'm checking it too. All right, so 2 and 3 and x to 2 here, bring down. Yeah, I'm happy with that. As you can see, I'm always careful, right? Even I'm careful, I'm this careful, I still make mistakes. So guys, you think about that. Okay, so next step, we're gonna transform the integral here, or it's called integrand, to everything in terms of u. So can we do 9? Okay, I'm just going to write 9x to the 5 here first. Seems like the denominator there is already a u, right? Okay. And then the x will be subs with this guy. Okay. Now, x squared can cancel. Yeah, so I have to the power of 3 instead. And then I can cancel 3 and 9 here using 3. Okay, so I have 6 in front of the integrand because 3 and 2 here. And then x to the 3. Okay, so if we, from the substitution there, if we square both sides, we get u squared equals x to the 3 plus 1. So if we move 1 to the other side, we get u squared minus 1 is x to the 3. That means we can subs x to the 3 here being u squared minus 1. That's over u there. All right. That's nice. And then the 2 and the 3 already got away. So this is x to the x plus 1 square root. So that is kind of also u, right? So that's the whole thing is u. So u here get canceled. So nicely, guys, we have integral of all that instead. So that would be u to the 3 over 3 minus u. Okay. And a plus c, of course. So u is actually, yeah, so u to the 3, it is that whole lot x. Yeah, we need to change it back to the x term. So because this is to the power of 3, but we already have a 2 over 2 there. So I have the power of 3 over 2 because this is to the power of 1/2. Okay, and this is minus. Ooh, minus. Okay, it's okay. Hang on. I need to slow down a bit. I need to factorize u out, I guess. Yeah, let's do that. Okay, so ignore the c for now. We can put that back in anytime. We're gonna factorize u out, right? Let me think about that. Okay, so I need to take 1/3 out as well. So like that, and then interesting. Okay, I'm just gonna take 1u out, and then that's gonna give me u squared over 2 minus 1. All right, and plus c, whatever. Okay. Wait. Okay, yeah. So this is 6. U is square root of x cubed plus 1. So u squared is going to be x cubed plus 1 over 2 and minus 1 here plus c there. I hope this is going to work. And then we're going to multiply that. So if you simplify the fraction here, 2 multiply minus 1 here, that's going to be minus 2. And then that's going to give this minus 1 all divided by 2. Okay. Yeah, we get the same thing there. And now we can bring this 2 out. So we get a 3 here. And this will be x to the 3 plus 1 to the power of 1/2. Yeah, that's the k. Okay, and then this is x to the 3 minus 1 because we already brought the 2 outside, but hang on. It is not what we want. Oh, my bad. This should be a 3. Hang on. What was that? It was, what was that? This is over 3, right? Yeah, because it's integrating. Yeah, okay. How can I, yeah, stupid. This is 3. See, guys, I made a mistake here. So hang on, I'm a bit confused now. 6u Okay, this is u squared, so this is still over 3, right? So this is a -3, this should be a -2, and that should change to a -3. All right. Yeah, we got it. And this is now a 2. Cool. Yeah. Oh, and this is a 2. Right. Yes, now it's okay. Everything is fine. Plus a C. That's it. Done. Number 7, guys. Okay, so show that blah, 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 where A and B are constants to be found. Okay, this is partial fraction, so we need to do a long division first for that. I mean, it doesn't seem that long, but anyway, so x plus 2 dividing into 3x minus 1. So this is going to be 3, right? So 3 and then 3x plus 6, subtracting both term, that goes away, and that would give me -7. So that means 3x minus 1 over x plus 2 will be 3 being the quotient plus the remainder -7 over the divisor x plus 2. That's easy. Okay, that's part A. Part B. The finite region R, okay, shaded in figure 4, bounded by the curve and the line of equation x of 4 and x of 1. The region is rotated through 2 pi radians. Okay, so the volume of revolution, the volume of solid revolution is equal to, hey, what was that again? I think it's, I forgot, hang on. Is there a formula sheet for this? Yeah, there is, but let me just think about that. It's integral of y squared dx, right? Yeah. And then pi here, right? Yeah, it is, right? I'm gonna take my risk there, but I think it is. Yeah. Pi r squared h. I think it is, guy. Yeah. Um, yeah, okay. So we're gonna integrate the y squared from 1 to 4. So let's put that in. Y being that whole lot, which is already found in partial fraction there, but we need to square that. Okay, that's going to be a little bit more horrible there. And limit is from 1 to 4. Okay. Okay, so we can expand that first because we can't really use any reverse chain rule there. So this is going to be 9 minus 2 times 3 times 7. So that's -42. And this is going to still be that. But the last term would be 49. That would put to squared instead. Okay. Okay, now we're gonna integrate separately, guys. So carrying around pi and the bounds here. Actually, I'm gonna integrate it already here. So I'm gonna get 9x, yeah. This is gonna give you a ln, so it's 42 a ln modulus x plus 2. That's done for that. And this one will be, so that is actually that, right? And we can use a polynomial integration. So polynomial integration says that I should have that to the -1 and divided by -1. So that's going to turn that to a minus coefficient there. Okay, so am I happy with everything there? I think I am. Yeah, but I'm going to write this to that instead, right? I don't like writing it up there, maybe. Okay, so that is fine. Now, bounds. Last time I made a mistake about bounds. I won't make it again. Okay, 1 to 4. So that's it. We're gonna just simplify all of this and get the answer. All right. So again, my general technique would be doing each term, not each set. So x here would be a 4 minus 1 inside. 4 substituting in. So what do I get? A ln. So this is 42 with a ln 6, right? Minus ln 3 inside there. Okay. And this one here is going to be 49 and then 1 over. So I'm just extracting 49 out, factoring it out, and It's basically 1 over 4 plus 2 there, which is 1 over 6, and minus 1 over 1 plus 2, which is 1 over 3. So this is how I would do it. Much simpler to write and easier to see, yeah? And then I'm going to simplify all that. So this is 27, yeah, basically. Ln 6 minus ln 3, so you can divide them and then get ln 2. So that's 42 ln 2. Okay, so this is, yeah, it's going to turn positive there because this is less than. Okay, so 3 minus 6 is minus 3. Minus 3 is just 3 over 18, so that's 1 over 6. Yeah, that's 1 over 6 basically. I shouldn't have used that. Okay, this is 1 over 6, so that's going to turn positive because all the minus sign will cancel. Yeah, I'm happy with that, I think. Okay. Now simplifying a little bit more, we have a ln 2 there already, so we're just going to simplify these two guys and get the answer there and be done. So, okay, calculator, 26 times 3. Wait, hang on. 27 times 3. Why did I say that? Wait, no. 27 times 6. All right. So that is 162, and then I'm going to add 49. So I get 211 over 6 here, minus 42 ln 2. Am I okay with that? P and Q are rational constants. So there is a likelihood that I'm right because they are rational constants here. But yeah, let's come back, check that later, right? It's not like I'm too confident with that, but I'm going to check this one later. I'm just circling it first, okay? Okay, so next one. I think our time is still okay, hopefully. Okay, relative to fixed origin, now vectors, guy. Find a vector equation for L1. Okay, so yeah, finding the equation is quite easy. You just subtract them and then take one of them to be the A. So basically it's the R equals, you can do like what? So I'm going to do like AB. Hang on. So I'm going to take OA here as point A as A. So wait, let me write the equation. So this is vector A plus lambda B, where you can take B as the relative vector from A and B. So I'm going to take one of them being minus 10, 5 minus 4 plus lambda, and then this is going to subtract, right? So just going to do AB. I'm just going to take B as A to B. So I do B minus A, so minus 6 minus minus 10. A minus B, hang on. Is it B minus A? Yeah. 4 minus 5, and then minus 1 minus minus 4. So minus 10, 5 minus 4 plus lambda. Let me check that again. Yeah. Yeah, I think I'm happy with that. So this is 4 minus 1, 3, right? Yeah. So that's my vector equation. Okay, for L1. And find a vector equation. No, the line L2 has equation that where P and Q are constant and mu is a scalar parameter. We already have a lambda here. Find the value of P and Q. Oh, it gives you that y L1 and L2 intersect, so we can equate the two. That means we can do like, so this is going to be minus 10 plus 4 lambda, 5 minus lambda, and minus 4 plus 3 lambda from L1. And then we're going to equate that to L2. So 3 plus 3 mu, just expanding that in. And then P minus 4 mu. And then Q plus just 1 mu. All right. And then because these are equal from vector method, we can say that we can use 3 different equations simultaneously to solve for all of them. All right, so this is basically we want to solve. Okay, so how do we solve? That's another question. Okay, so it seems like, So if we take the first two, what do you say? We take the first two. Right. Okay, let's do something, right? Let's do something. Okay. Um, okay, so I'm just going to take the first two. So this is equation one. Yeah. And then equation two, I'm just going to multiply the second line here by 4 maybe. So I'm getting 20 minus 4 lambda equals 4p minus 16 mu. All right. So adding them up, I would get 10 and lambdas go away. Yeah. And then this is 3 plus 4p minus 13 mu. Right? That's the fourth equation maybe. And then, okay, this is first one, second one, third one. All right. And then, okay, I'm just going to write here 4 times equation 2 there. And then if we pair again, like we keep the mu. Okay. Yeah, that's probably the only way. It's 3 equations with 4 variables. How are we going to find that? That's not possible, is it? My time is ticking, guys. Oh, I see something. I see something, I think. No, I don't see anything. Look, if I add them all up, like 1 plus 2 plus 3. So here I'm just adding everything up. I'm going to get minus 9. And the lambda here, let me check the lambda again. It's like it should just cancel or something. Yeah, if I take that, yeah, sure. All right, that's fine. Yeah, okay. So I add them up, I get minus 9 there. This is going to be 6 lambda, right? Equals 3 plus p plus q. And then mu goes away. All right, that's why I did that. So this is in terms of lambda and p and q. Okay. Okay, now I'm going to try do 3 times second equation. I get 15 minus 3 lambda equals 3p minus 12 mu. And I'm going to add that with the third equation. Okay, so add that with third equation, I get so 15 add minus 4, I get 11. The lambda goes away. That is 3p plus q minus 11 mu. We have too many equations already now. We get 3 more equations. Hang on. This is also my 5 equation. Hang on, 5th equation, and then I'm going to delete this. Is there a point here we do all this? I hope there was. There doesn't seem to be. Am I missing anything? This is horrible. Okay. Wait. I'm going to come back to this, right? See if I have time. Okay, so let's do B. Find the value of P and the value of Q. Okay. Wait, no, that's B. So we're at C. Sorry. I must be blurred right now. The acute angle between L1 and L2 is theta. Find the exact value of cos theta. So yeah, so we use the vector B's for both vectors to find the angle. So B of L1 is equal to just the one we found there is 4 minus 1, 3, and then B of L2 is wait, what? Huh. Wait. This is interesting. It's just I just found the numbers to be like the other way around, but hang on. Okay. Cos theta is just the two dot product, B1 dot B2 divided by modulus BL1 modulus BL2. Yeah. So if you dot them there, 4 dot 3 gets 12 plus 4 plus 3 on top there if you do the dot product. And then at the bottom here, I think they have the same magnitude because we have 4 and 1 and 3 and 4 and 1 and 3. The sign doesn't matter. So this is just 16 plus 1 plus 9 for the absolute, because you're going to have square root of 4 squared plus 1 squared plus 3 squared. And then you multiply them here. So the square root sign cancels. All right. That's why I did that. So cos theta is going to be 19 over 26, right? So that means theta, exact value of cos theta. That's done. So we want the exact value. So there you go. That's it. Now D, given that the point C lies on L2, okay, such that AC is perpendicular to L2, find the exact length of AC. So we can't get the accuracy mark for this because we haven't done P and Q, but I'm just going to go ahead and say that, okay, P is 2 and Q is 5, all right, somehow. And then I'm going to use that as my L2, right? So C lies on L2 such that AC is perpendicular. Okay, so this is line L2. And then C is here and A is somewhere. A is that. Yeah, that point there, that's point A. And AC is perpendicular to L2. Okay, so we just have a graphic there. So that means A to C would have to be perpendicular. We want to find the exact length here. Let's say length A. So, okay. So, okay. So we do vector AC first. Yeah, C lies on L2. So if C lies on L2, the coordinate of C would be all that. So we just got our line here. So P is 2, Q is 5. So it's going to be 3 plus 3 mu, 2 minus 4 mu, and 5 plus mu. That's my point C, for example. And then I'm going to dot product. Wait, hang on. I'm going to do a minus with my A here first to find AC. And this whole thing will be a dot product with the line L2. So we're just going to use the directional vector here, I call it, which is this guy. All right, 3 minus 4, 1. And that should equal 0, right? Yeah, so that's it. So 2 plus 3 mu plus 10, 2 minus 5 minus 4 mu, 5 plus 4 plus mu, dot with that should give me 0. And then I can solve for mu and then use that mu to just find points, exact length of AC. So exact length of AC, we need to find mu for C first and then find the length. So I'm just going to take the first one here because I think it's going to be wrong. Yeah. Wait, okay. I need to do all of those. Okay. 3 times 12 plus 3 mu plus minus 4. This is minus 3 minus 4 mu plus 9 plus mu or equals 0. Okay, I'm going to have to solve that equation. I'm going to collect the mu. So this is 9 mu. This is 16, which is 25. 25 plus mu there is 26. 36 plus 12 is 48. 48 plus 9 is 57. Yeah, equals 0. So mu is going to be a negative value. That's fine. We don't mind that. And then we're going to use this to find the coordinate of C. So point C is at OC actually. So OC is this guy right here. 3 plus 3 minus that. And then 2 minus 4. That substituted in. I'm just substituting back in here, guys, for the mu we found. And then 5 minus 57 over 24. My time is ticking. Okay, this is OC, right? If we want to find the length, we just, wait, hang on. We can just find AC and do Pythagoras. Yeah, okay. So we actually find the inside here. So this is AC instead. And we're going to also include that. So that's going to be plus 10 here. And this is going to be minus 5. And this is going to be plus 4. That's horrible. And then we're going to do the length of that equals square root of, so let's take that as x, y, and z. And we do x squared plus y squared plus z squared. And I'm going to make it something like, exact length. Let's say square root 10. How about that? Because I don't know P and Q, so I'm going to make that up, right? Just to get some method marks. And then question 9 now. See, we have question 10. We do. Okay, just 9 and 10, guys. I think we are fine. Partial fraction. All right, so let's do. So 1 equals, hang on, let's do this first. Okay. So it's going to be a over x plus b over 2x minus 1. That's just the partial fractions first step. And then I'm going to have 1 equals doing the cross multiply there. Okay. So I'm going to let x be 0 first. So that's going to be 1. X being 0, I get a minus a here. So a is minus 1. Then I'm going to let x being the other critical value being 1/2. So 1 equals, a goes away. So b 1/2. So that means b equals 2. Okay, so that means that in the form of partial fraction would be minus 1 over x and then plus 1/2. No, sorry, 2 over 2x minus 1. All right, so that's it. And then solve differential equation that. So we have, and show that. Okay, we're going to solve this differential equation by separation of variables. Yeah. So basically it goes like we need to move h to the same side as dh. So I'm having like that maybe. So I might bring 50 up here and then h and 2h minus 1 here. And we see that that's the reason why we did the partial fraction here. Okay, let's do that. Okay, so I'm making the left side being that, and the right side is just cos t over 10 dt. So this is dh. All right. Yeah, everything is fine. So integrating both sides, yes. And this will turn to, I'm just going to take 50 outside because I don't like it playing around inside. And then we're going to take the partial form there, swapping to make it a little nicer. So 2 over 2x minus 1, we're going to change it to 2h minus 1. And this is a minus 1 over h. integrating that respect to dh, and on this side, well, okay, just write down first. Yeah, never mind. Okay, and then integrating either side, both sides, so we have 50. So this is going to be 2 ln to h minus 1, right? And minus ln h. But don't forget, we have a reverse chain rule here, so we got to cancel the 2 out, so I don't have any 2 there because it's going to be divided by 2. Okay. And then, yeah, we have some bounds, right? Never mind. Yeah. So the start of the ride, the carriage is 2.5. Yeah, above the ground. Yeah, we can put that into yeah, okay. You know what I'm gonna do? I'm gonna just, so this is the tactic, because you already have the boundary conditions there. So I'm gonna put that in later, but let's integrate first. So we will put some bounds in here. So integrate cos, you get sine, so sine of t over 10. But then the reverse chain rule says that you have to divide by 1 over 10, so that's going to be multiplied the 10 there. And then here, I'm going to put a bound covering the sign there. Okay, so at the start, that means t equals 0, right? The height is 2.5, so I'm putting 2.5 here. And at t equals t, height equals h. If you solve these bounds within the integration, you're going to get that equation, the final equation you want, without having to find any constant c. So that's not going to bug you there. But inside here, let's simplify a little more because I would like that. So that's going to be actually ln. If you try put 2.5 in there, you're not gonna get any negatives. So I'm just gonna take the modulus out. So I have a 2h minus 1 here over h. All right, 2.5 and h. This is okay. So 0 put in there, we get 0. So it's just 10 sine t over 10 already alone. Okay, so carry on with that. We get what? Okay, so we're gonna put in the bounds now. So that is ln. I'm gonna have the h first, and then I'm gonna minus that by the other bound, which is ln 2.5 times 2 is 5. 5 minus 1 is 4. So that's 4 over 2.5. 4 over 2.5, I get 1.6, which is 8 over 5 in it. Yeah, okay. Oh, I forgot that we can cancel that as well. So this is 5 alone, and that is sine t over 10. Okay. So what do we have to do? We have to make h the subject. Okay, okay. So okay. So we're gonna, all right, hang on, let me think a bit. Okay. So let's move 5 down here. Yeah, 5 down there. And we have only here 2h minus 1 over h minus ln 8 over 5. If we move ln to the other side, we get that plus ln 8 over 5. All right. And then now doing the magic, we doing the inverse here. So I'm going to put ln to the other side as the base e of that all power of the right side. So I have e to the everything there. Okay, k is a constant to be found. So I think I'm fine with that. So e to the 1/5 sine t over 10. Okay, now because this is a plus ln, I can do e to the ln 8 over 5, right? Because it's like you can use laws of indices there. A to the m plus n equals a to the m times a to the n. So this is the same thing. Okay, now but I have 2h minus 1 over h here. That's e to the 1 over 5 sine t over 10. This is 8 over 5, right? Because E and ln cancel away. Now, how do I deal with this? So okay, so 2h minus 1 equals h and all that, right? So that means if we want h as the subject, so h must be equal to, if we move h to subtract the other side, and then 1 would be have to be the dividend there. So that would be, so we move this whole lot to subtract 2h, and then when you factor h out, it would be 2 minus this whole thing, yeah? Including times 8/5 there. Yeah, I think we're getting close. So if we multiply everything by 5, we're going to get there. So multiply by 5 and 5 there. So we get 5 on top. Yes, good. And then 10 here. Yeah. And then that would cancel that. I get 8 e to the 1/5 sine t over 10. Woohoo. Yeah, I got it. As required. And then C. Wait, what? Okay, this is B. B is long. But I got 6 marks, I think. Hence, find according to the model the time taken for the carriage to reach its maximum height above the ground for the third time. Give your answer to the nearest second. Okay, now maximum. Maximum, this function, it can only be maximum when, so h is maximum. We just have a look at only some particular function. H is maximum when this guy is minimum. So we want the denominator to be minimum, right? When 10 minus 8 e to the k sine t over 10 is min. And this is minimum when, okay, so that's minimum when e to the k sine t here is maximum. Yeah. Okay, so e to the k sine t over 10 should be maximum. Okay, we want that to be maximum. And that can be maximum only when sine t over 10 is maximum, right? Because that's the power there, isn't it? Yeah. And sine t over 10 is maximum when, well, sine t over 10 is maximum when it is 1, because that's the maximum value it can be, right? Yeah. Hang on, so, ooh, e to the 1/5. So let's put that to 1. Okay, so if, because we already know that k is equal to 1/5, right? So if sine of that is 1, hang on, where's the calculator? So if sine of that is 1, it's going to be e to the power of 0.2, which is 1.22. Yeah, okay. So this should be it. Okay. Yeah, right. So t over 10. For the third time. Ooh, okay. So how can sine be 1? Pi over 2, 3. What's the next one? Pi over 2. That's gonna add 2 pi, so 5 pi over 2, right? And then 7 pi over 2. No. We're gonna add 4 over, yeah, add 4 pi over 2, so that's 9 pi over 2. So the third time is this guy. That means t equals 10 times 9 pi over 2, so that's 5. 45 pi. 45, come on, man. And that is to the nearest, whatever it wants there. Third time, nearest seconds. So t is already in seconds in it. Yeah. So that's 141 seconds. Okay, that's done. The last question, and I don't have the time to fix that one. I left the whatever that was. Show that the area R is that. Okay, integration by parametric. So integral y dx is the same as integral y dx by dt, because if you cancel the dt, you get dy y dx, the same thing. But because we have parametric, that's going to be useful. But here, y, note that it's going to be in the parametric form, which is in terms of t. So I'm putting y in terms of t there. And then dx by dt, if you're differentiating dx by dt here, you get 6t, right? So I'm putting 6t in here, and then dt, okay? So we're going to show that we get that as the area. Okay. Okay. Yeah. Okay. So we use double angle there. 2 sine t cos t and times 6t and dt. But because we need to put in bounds of t, so obviously that is when y equals 0. So we put y equals 0 there. That means sine t equals 0 or sine 2t equals 0. Now sine t equals 0, this is t equals 0, obviously. Sine 2t equals 0, this gives t equals pi over 2, right? Yeah, because sine pi is also 0. Yeah, okay, so that's pi over 2. Yeah, so here we go. Pi 0 and pi over 2 for the bounds of t. Okay, I'm just, yeah, note that. If you multiply that all out, k is a constant to be found, so we have another t there as well. So just tidying everything up here. So t in front, we have a sine, both of the sine squared here, and 6 multiplied 2, we get 12 out here, and then 1 cos here and dt. So that's fine, as required for A. For B, okay, for B, hence using algebraic integration to find the exact area. Okay, exact area, guys, exact area, that's fine. Okay. I have a t here. All right. So what can I do then? By parts, right? Yeah, almost forgot. So let u equals t and dv by dt equals, I can integrate that, can I not? Okay, let me check. All right, this is tricky, no? If I integrate that, what do I get? Yeah, I can integrate that. I think I can. Right, let's see if I can. Okay, so du by dt is 1. An integral that, which gives us v, would be integrate that, which I happen to know that if you differentiate sine, you get a cos. So that should be a sine cubed t over 3. Yeah. If you try differentiate that back, you should get that, right? Yeah. So integral of that. See, yeah. Okay. T sine squared t cos t. I don't have much time to write now. So uv, so u and v minus integral du, which is 1, and v is that. So we're going to have to integrate that again. Come on. So that's t over 3 sine cubed minus. Okay, integrate sine cubed. Are you serious? Integrate sine cubed. That's horrible. That is horrible. That is very horrible. Okay. I'm out of options. Okay, I'm out of luck here. I don't think I can integrate that because I can't do anything with that. Okay. because we can't use any formula there. It's just impossible. This is not good. Okay. You know what? I'm gonna give up for that one. Maybe I'm gonna just put the bounds here, being okay, 12 here, and then just put 0 and pi over 2 here and give up because I'm out of time, basically. Okay, okay. I'm gonna sure work on the correction here, right? So stick to the video, and yeah, so after I mark the paper, I'll give you the correction, all right, in this one. So my bad. Okay, so I think that's it. I'm gonna call it. Okay, stop the timer and mark the paper. Okay, guys, this is the mark scheme for P4 October 2024. See how much I got. All right. I'm a bit excited too. Okay, yeah, the first one almost flopped there. Everything was fine. And then the second one, yeah, that's good. That's good. The second one here, no solution, so no intersection. Yeah, okay. All right. Yeah, I'm fine with that. Number 3, yeah, we approved dy by dx to be that. And then, okay, that's still fine. C, yeah, I didn't manage to, wait, hang on. Oh, this is fine, yeah, 3 minus 3, yeah. Okay, that should all be correct, yeah. Number 4, 1 is 2, yeah. So lies on C because we proved that to be so. And then we have managed to do the derivative, find the dy by dx here. Everything looks fine except why is that e to the ln x ln 8? Oh, hang on. I should look at this form. Hang on. Yeah, so this is just the minus flop. So yeah, I think I got it. Yeah, that's fine. And then that is just correct. All right. 5a. Okay, I proved that. And 1 over 18 at the end. How wonderful. No silly mistakes yet, guys. This is also should be okay. I look at the end and then I got everything right. So everything should be right. That is fine as shown as required. This is good. I got everything here. Didn't have to check back. Now this one in it. This one is a real problem. Okay, so yeah, I must get one of the vectors there. So this is it. This is the one. Got that one. And then what? I didn't see that. Wait, hang on. -6. What? Okay, so they just equate the vector. They just equate one of the coordinate to -6, which is either A or B. I think it's B. Wait, how come? Does it say it passes phi? Now I wonder. Let's bring back the question again. Okay, so how come can you do that? Oh no! It says intersect at B. Oh my God. Oh my God. I need to, I need to hit my head at the wall. Right. I didn't see that, honestly. I just see L1 and L2 intersect and that's it. My brain stops reading after that somehow. So this is easy now, guys, because you can just use the coordinates of point B to be, just put that in the L2 equation and you can solve much, much more easily than what I did, because I didn't see that. Yeah, so this is what they do. They just put the L2 coordinates to be at point B and solve for P and Q and everything. Everything can be solved. So they solve for mu first on the first coordinate X, and then use mu to solve for P and Q later. You can just follow along there. And then I just made my P and Q up. So I didn't get any method here nor the accuracy, so I lost 3 marks there. But let's see C, right? Okay, so what did I do? What seemed a much easier method there. Okay, this is still fine. I got that. But this one, yeah, hang on. I probably need to find the alternative, but yeah, so this seems like they do trick. So L2 must be L1 must be passing A. So I'm gonna make L1 this line instead. Okay, so let's say that L1. And then they intersect that B here. So the angle between L1 and L2 should be theta there. All right. So because you know B, you can already find AB. Let's say AB is K, the length. In this case, they found it to be root 26. And then doing the sign, yeah, this is a right angle triangle, right? Because AC is perpendicular to L2. So you do that, you get the answer. So AC is K sine theta. You know K, you know theta from the previous part, because the previous part cos is 19/26. So you can do, using identity there is 1 minus sine squared, you get 1 minus cos squared, you get a sine. So that's why they get that. Okay, so I lost everything here, maybe, or maybe not. Let's see if I have the alternative marks here. See if they offer alternative for the marking. Yeah, I think I got like the method mark to find exact value of LC. Yeah, I do the dot product there, exactly. Yeah, that's what I did. So I should get a method mark, 1. All that just for 1 mark, guys, and I lost another one. So in total, I lost 4 marks for this. And then there's another question I need to lose marks because I didn't quite get it. But this one, I think I got it. And I got it down here, yeah? I managed to prove the required form here. Yeah, as required. I think I'm going to pass on that. And for C, yeah, so exactly right. Good. That's just logical deduction there. I didn't do any integration or anything. And then the last one is that. So yeah, I got that proof fine. So I got marks for that. Now, what can I lose for B? Quite a lot. Okay, so let's see what they do. Yeah. Wait. So they do the same thing as I did. Okay, I got this. But I didn't quite do the 1 minus cos squared yet. But I got the first line here. So I got this M. But then the second M here is just changing that using identity, which I didn't use. Oh, are you serious? So you have to do it from here to here. And wait, hang on. What did they do? Yeah, they use the same biparts selection. But then after that, you need to do another. Oh, right. That's great. So I lost marks again for this one. Okay. Yeah, how much did I have to lose? 4 marks. I lost 4 marks for that in totality. Yep, and that is it. That's everything. So how many marks did I lose? -4 and -1. Wait, hang on. -1 here. So -5, -8. -8. That hurts. So I get 67/75 because I lost 8 marks. Okay, guys, the honest feedback here is that it was quite tough. I always say that, right? I mean, just realize now. But I am very careful for this paper because the 8 marks I lost weren't for the silly mistakes or anything. I didn't make any silly mistakes at all. It's just I didn't realize that it intersects at B. Maybe if there was any silly mistake, it was about me reading the question not properly. I don't know how well other people did in this year because as of the time of recording, there is no UMS calculation yet. So I can't really compare to anyone there. So guys, I hope along the way you have maybe collected some of my techniques, which I hope it might be useful for you. Don't forget to hit the subscribe button and don't forget to keep studying, guys. See you in the next video. Bye.